The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome back, guys. In this video, we're going to be talking about Laplace transform. My name is Dr. Avitech, and let's get started. Now, in engineering, especially electronics engineering, they deal with systems that would require us making our problems much more easier by a transform. So what we do is we take a particular expression or a function in a particular type of domain. So we change it to another type of domain, and in that domain it's much more easier. There are plenty of transforms, and basically for Laplace we're basically transforming from the time domain t to s. We're basically changing from time t to s. Now what we then do is we basically use an integral for this. So we could say that, oh, this is actually an integral transform because it involves integration. So what I'm going to do here is, let me first of all show you the expression of the Laplace transform of a function f of t. So there's a function f, and it's in terms of t. So what we're going to do is, it's written this way: Laplace transform f of t. So this is how we write the Laplace transform. Now, how do we then define this? We define this using the integral from 0 to infinity of the function f of t e to negative st dt. Now, if you use this very integral to transform this very function in the t domain or time domain, when you change it to s, your final expression will be in terms of s. So your final expression would then be in terms of s. Now, this very, this very movement from this point to this point is Laplace transform. So what we basically do is, we have f of t. We're going to put this into, we can say, a Laplace transform machine. We could put it that way, a Laplace transform machine. So we can actually put it this way. So we're going to take a function f of t, put it into a Laplace transform machine, and it's going to change it to f of s. So that is what we do here. That is what we do. And of course, if we have s, because basically, like I said before, in electronics engineering, we use this a lot. For students who are in engineering, they deal with transfer functions. They deal with transfer functions, and it's very important to make use of Laplace transform. It makes the whole work easier. Now, when you're done with sending your function into the s domain, or when you've taken the Laplace transform, thereby making your calculations much more easier, when you're done calculating, you need to change it back. Now, if you're moving from this point to this point, you're taking the Laplace transform. And then if you're moving from s back to t, you're taking the inverse Laplace transform. Now, here's the thing. We're going to be making some derivations. We're going to be making some standard, formulas, so that we don't use this integral all the time. Because if we know what the Laplace transform of some type of functions will give to us, it is much more easier to just have it offhand. So the first transform we'd like to take is the Laplace transform of a constant. What's going to happen if we have just a constant? Now again, another exciting, or let's say insightful, so another exciting application of this is we use it to solve differential equations. Yeah, there's some differential equations that are very, very easy to solve, especially if you have an initial value problem. So you just have the initial conditions given to you. You can solve first order, second order. You can solve differential equations using Laplace transform. So let's cut this video, and then let's go into the next video for us to talk about the Laplace transform of a constant.